So, you know how time travel is just everywhere? Sci-fi, late-night web searches, all that stuff.
Oh, yeah, completely. It's
Mhm.
one of those ideas that really captures the imagination.
Well, someone sent us this pretty blunt piece. It's called Time Travel is Bullshit. Comes from Dave Champagne and Zero One, part of Motion Theory.
Right, I read that one.
Yeah.
And they jump right in, don't they? They
Yeah.
basically say, maybe the problem isn't how to time travel, but our whole idea of what time even is.
Exactly. It's like, whoa, okay. So that's our mission for this deep dive. Unpack their arguments, figure out why they think time travel is, well, bullshit.
And it really starts with how we perceive things across vast distances.
Yeah, the telescope thing. That one jumped out at me straight away. We always hear, look through a telescope, see billions of years into the past because the light's traveled so long.
Mm-hmm. The standard explanation.
But motion theory, they call that the telescope lie.
Yeah, it's a strong claim.
Mm-hmm.
Their alternative is, well, it's different. They're not saying we aren't seeing distant galaxies, but they argue telescopes aren't just passively catching, like old photons that finished a marathon across the universe.
So what are they doing then, according to this theory?
They say telescopes resolve rhythmic structure, something that exists right now in what they call the motion field.
Okay, hold on. Rhythmic structure. Right now, not ancient light.
That's the idea. You're essentially syncing with a structure that's active in the present.
Mm-hmm.
And the fact that you can sync with it, that you can see it, that means it hasn't finished its pattern yet. It hasn't collapsed or resolved in their terms.
So seeing a galaxy billions of light years away isn't looking back in time.
Not according to them.
It's tuning into its current motion structure. Is that the term?
Structured motion, yeah.
Yeah.
Or rhythmic structure. It's like the universe is this massive web of interconnected rhythms, and telescopes let us perceive these patterns in real time.
And they claim all telescopes see the same structures,
Yeah.
not different streams of photons.
That's part of their argument, yes. That it's about detecting these fundamental motion patterns, not unique light particles with individual histories.
Wow, okay. And they even extend this to our own eyes, right? Saying we actively resolve motion, not just passively see light.
Exactly. It's not photons hitting your retina after some long trip.
Yeah.
It's your visual system actively engaging with this present moment motion field,
Yeah.
even across huge distances.
So the big takeaway from this part is no looking back into the past. It's all real-time resolution.
That's their conclusion, which, really makes you pause and think about those incredible images from Hubble or Webb. Are we seeing the universe as it is right now?
It definitely shakes things up. And I guess if you throw at the idea of seeing the past like that, it sets up their whole argument against traveling to the past. Which brings us to the next bit, why they think time travel just logically falls apart.
Right. They say, look, for time travel to work, you need two things. One, a physical dimension called time.
Makes sense.
And two, you need to be able to, move through it, forward or backward.
Okay. And motion theory says?
They challenge that first point head on. They state it pretty clearly. Time is not a dimension.
Not a dimension. So what is it then?
They define it as a local rhythm difference.
A local rhythm difference. Okay, let's unpack that a little. What does that mean practically?
Well, think of it like this. Time isn't a road you can walk down. It's more like a comparison. How fast or slow the internal beat or rhythm of one thing is compared to another, right where they are.
Like comparing clock speeds.
Sort of, but more fundamental. They use the analogy, you can't travel through the number 5, right? It's a concept, a measure.
Okay.
And they argue you can't travel through this rhythm difference either. It's a measure of relative motion rates, not a place you can go.
Gotcha. So those examples like GPS satellites, their clocks run faster.
Yep.
And astronauts on the ISS aging slightly slower. Mainstream physics says that's time dilation, right?
Right.
Time stretching and squishing because of gravity and speed.
Exactly. That's the standard relativistic explanation. Space-time warping.
But motion theory has a different interpretation based on their rhythm idea.
Completely different. It fits their model where time isn't this traversable dimension. It all comes back to structured motion.
So how do they explain the GPS clocks running faster if not time dilation?
Okay, so their idea is everything is made of this structured motion, internal loops, rhythms, cycles, and the rate at which these loops complete or resolve depends on the environment.
Environment like gravity and speed.
Yes, but they reframe it. For the GPS satellite, it's further from Earth's structured motion density. That's their term for what legacy physics calls gravity's influence.
Structured motion density. Okay.
And it's moving fast. These two factors, distance and velocity, change how the satellite's internal rhythms sync up with Earth's rhythm.
Oh, so it gets slightly out of phase, like listening to music slightly offbeat.
That's a great analogy. It falls out of sync with Earth's underlying, let's call it a compression rhythm. Because it's less coupled, its internal loops finalize at a slightly different rate compared to a clock on Earth.
So the clock is physically different, but not because time passed slower or faster for it,
Right.
but because its internal count, its rhythmic cycles, completed fewer or more times relative to Earth due to this sync difference.
Precisely. They stress it's about experiencing less synchronized motion resolution, not experiencing less time itself. It's like your clapping analogies start together, but if one person's rhythm is slightly off, they finish at different moments.
So the clock change is real, but the reason is different. Fewer rhythmic loops finalizing, not time itself changing speed.
Exactly. And they even rename time dilation. They call it resolution rhythm mismatch.
Resolution rhythm mismatch.
And it's all down to how compatible these rhythms are and how they sync or desync across different motion gradients. No need for a flexible time dimension.
It's a very different way to conceptualize it. So what does this mean for things like the twin paradox, that classic thought experiment?
Ah, yes, the twins. One stays home, one zooms off, and a rocket near light speed comes back.
And the traveling twin is younger. Standard explanation. Time literally slowed down for the traveler.
Right. Relativity says their clock, their biology, everything ran slower due to their speed.
But motion theory, sticking to their guns about rhythm, what's their take?
Predictably, it's about the rhythms. They'd say the traveling twins' fundamental motion rhythm gets shifted because they're moving so fast relative to, say, the solar system's background rhythm.
Shifted how?
This shift means their internal processes, their biological sync events, finalize less frequently compared to the stay-at-home twin. They become less aligned, less rhythmically compatible with their origin frame.
So again, they age slower not because time slowed, but because their internal rhythmic count, the number of finalized biological cycles, is lower.
Exactly that. Fewer sync finalizations occurred within their structure. It's about structured motion alignment loss, not time dilation.
And again, no need for warped space-time in their explanation.
Nope. It's all about relative motion affecting rhythmic synchronization.
Okay, if time isn't a dimension and you can't travel through it, and these effects are just rhythm mismatches, then the classic time travel paradoxes must just evaporate.
That's where they go next, yeah.
Yeah.
Especially the big one.
The grandfather paradox.
The ultimate time travel headache, right? Go back, prevent your own existence somehow. Maybe stop your grandparents' meeting.
Yeah, and then how could you have gone back in the first place if you were never born? It's a perfect loop of illogic.
A real knot. And it's often seen as a fundamental reason why backward time travel, at least, might be impossible.
So how does motion theory cut this knot?
Quite simply, actually. They just say you cannot travel back into a rhythm that is already resolved.
Already resolved, meaning finished, done.
Pretty much. Once a pattern of structured motion has completed its cycle, it's no longer active in the motion field. It's like a footprint in the sand after the tide has washed it away.
So there's no past location to actually travel to, only leftover traces.
That's their view. The past isn't a place, it's a series of finalized motion states.
Right.
And you can't interact with or sync with something that's already finished and gone from the active field. They use the analogy of trying to, like, surf a wave after it's already crashed on the beach.
The wave just isn't there anymore in that form.
Exactly. It's dissipated. So the past isn't somewhere you can visit. It's done, resolved, which means
you can't go back and interfere with your grandparents because that time, that specific rhythmic state, doesn't exist anymore as an accessible thing.
Precisely. The paradox dissolves because the premise, traveling to an accessible past, is impossible in their framework from the get-go.
Okay. So if the grandfather paradox is out because the past isn't visitable, what about other paradoxes, like the bootstrap paradox?
Right, where, say, a future invention gets sent back, inspiring itself, with no clear origin point.
Yeah, that kind.
Same logic applies for motion theory. Resolved rhythm can't regenerate. You can't send something back into a completed state to start a loop because that state is inaccessible. The past is done.
No entry.
No entry, and therefore no bootstrap.
What about simple temporal loops? Getting stuck repeating the same day or something?
Again, if there's no accessible past state to loop back to, then there's no way to create such a loop across time.
It all hinges on that inability to access resolved rhythms.
Absolutely. And they even apply this to things like wormholes. The theoretical tunnels through space-time.
Sometimes proposed as time machines, yeah.
Well, motion theory would say even if you could bend space like that, you'd only be manipulating the current motion structure. You wouldn't be opening a door to a past rhythmic state that has already resolved and ceased to be active.
So bending space doesn't equal rewinding the universal rhythm track.
That seems to be their stance. So yeah, all these paradoxes, grandfather, bootstrap, loops, they all fail for the same fundamental reason in this model. Time isn't a place. It's just this measure of rhythm compatibility. There's no timeline, just motion syncing and desyncing.
It really reframes everything, doesn't it? This whole deep dive into time travel is bullshit. It forces you to really question what time actually is.
It does. It shifts your perspective entirely. You're not a potential time traveler navigating a fourth dimension.
Instead, you're a sync
participant. That's the idea. You're constantly part of this ongoing unfolding of the motion field, always syncing and desyncing with all the other rhythms around you.
It's definitely less romantic than sci-fi time travel.
Oh, yeah, maybe less adventurous. Their final motion drop, as they call it, is pretty stark.
What was it again?
Time isn't real. Travel is impossible. You can't visit what doesn't exist.
Blunt. So no TARDIS, no DeLorean. We're just participating in the now, syncing with the universe's rhythm.
That's the picture they paint, a radically different framework.
It leaves you wondering, though, if this is how time, or rather rhythm, works. What else does that change about how we understand, well, everything, reality itself?
That is the big question, isn't it? If time as a dimension is off the table, what other foundational ideas might need rethinking? Definitely food for thought.
Absolutely. Well, thanks for diving into this really challenging source with me. It's certainly given us a lot to mull over.
My pleasure. Always interesting to explore these alternative perspectives.
Indeed. Until next time, keep questioning.